I decide I want to go to Darien Lake and I want to take a few of my students with me. I make a list of the people who are interested in going and I have 10 of them. Unfortunately, I can only fit 3 people in my car with me, and so I have to pick 3 out of this list. I decided to pick Razia, Colin, and Carolyn. I posted their names on the board so everyone would know who is going with me. The order of the list doesn't really make any difference. I could list Razia first, Colin second, and Carolyn third, or I could put Colin first, Carolyn second, and Razia third. Either way, the same people are going to Darien Lake with me, and it didn't really make any difference how I listed them out. When I list things out and the order doesn't matter, we call that a combination. Combinations have neat notation, just like those permutations did, except instead of a P, we have a C. 10C3 means I have 10 people who wanted to go to Darien Lake, and I'm going to choose 3. The order doesn't matter that I pick them in, and that's why it's a combination. I can use my calculator to evaluate this. 10C3 is 120. So of the 10 people who are going, I could have made 120 different groups to bring with me. Example B, we have 8C4. Evaluate that. We plugged it in our calculator, and we ended up with 70. If we had 8 students interested in going, and we were picking 4, there are 70 different groups of 4 that we could choose. Finally, we have this weird-looking fraction in parentheses, 12 over 9. It's not really a fraction, though. What it really is a combination. It's another way to write 12C9. 12C9 is 220. 12 students are interested in going, and I'm going to pick 9 of them. There are 220 different groups of 9 that I could create. Let's take a look at a couple of examples. We can use this formula here, NPR over R factorial, in order to find the value of a combination. Of course, with technology, we typically just put it into our calculator. In our second example, we have Mrs. Fitzsimmons. She has 10 boys in her class and 20 girls. She wants to create groups of 3 students to work on a project. She has 30 students in total, and she wants to pick 3 of them. Because it doesn't matter what order she picks the students in, we have a combination, 30C3. We can evaluate that, and we get 4,060 different groups. So there's a total of 4,060 different groups that Mrs. Fitzsimmons could make, having 30 students in her class and picking 3 for each group. What if she has certain criteria? She wants each group to have 1 boy and 2 girls. Well, here's what we have. There are a total of 10 boys, and we're going to choose 1. So we have 10C1. There are 20 girls, and we're going to pick 2 of them, 20C2. We multiply those 2 numbers together, and we end up with 1,900. There are 1,900 possible groups that she could create with 1 boy and 2 girls. In example C, she wants a group that has 3 girls. She has 20 girls. She's going to choose 3 of them, so we have 20C3. She could make 1,140 groups of 3 girls. Next, suppose Mrs. Fitzsimmons decides she wants at least 2 girls in her groups. Well, that means she could have a couple of things. She could have 2 girls and 1 boy. 2 girls and 1 boy is 10C1, that's my boy, and 20C2. Or she could have 3 girls. There's 20 girls, and she's going to choose 3 of them. We do the math. We take 10C1 times 20C2. That's the group of 2 girls and 1 boy. That's 1,900. Or she could choose 3 from her 20 girls. That gives her 1,140. We add those together, and there's 3,040 different groups she could make that have at least 2 girls. Suppose we have 10 teachers in the math department. We want to know how many 4-person committees can be formed in the department if Mr. Dory and Mrs. McCann, who are two of the teachers, must be on the committee? Well, let's think what we have here. First of all, does the order we choose the people to be on this group make any difference? No, it doesn't. We're choosing 4 people, and so I draw my 4 lines. The first 2 spots are for Dory and McCann. We fill those in. There's only one possible choice for each one. Next, we have 2 more spots left. We have 8 teachers remaining, and we're going to choose 2 of them. Because the order does not matter, we have 8C2. 1 times 1 times 8C2 is 28. There's 28 different ways that I could form this committee. Next, we have the math club, where it's hip to be square. There are 14 teachers in this math club, and we want to know how many 4-person committees can be formed by using the members of the club. Please pause here and see if you can find this answer. Let's see how you did. We had 14 teachers, and we wanted to choose 4. The order doesn't matter, so it's a combination. 14C4 gives me 1001 different ways that I could form this committee. In example B, we want to form a 4-person committee, but this time Mr. Duntley really wants to be on the committee, and so we choose him for the first spot. We want to choose 3 more teachers. See if you can find out how many different groups I could make if Mr. Duntley must be the first person. Pause here and then come on back. We have 1 choice for the first spot, that's Mr. Duntley, and we have 13 teachers remaining. We're going to choose 3 of them. Because the order I pick them doesn't matter, I have a combination. 1 times 13C3. That gives me 286 different groups I could form by choosing 3 teachers along with Mr. Duntley. How about part C? How many different 4-person committees can be formed if Mr. Dory and Mr. Serbone, who are also in the club, must be on the committee? We have our 4 spaces to fill. See if you can fill those in and determine the number of committees that we could form. We have 1 choice for the first spot, that's Mr. Dory. 1 choice for the second, that's Mr. Serbone. Then we have 12 teachers remaining, and we're going to choose 2 of them. Because the order I pick them doesn't matter, it's a combination. 1 times 1 times 12C2 gives me 66. There's 66 different groups that I could form that have Mr. Dory, Mr. Serbone, and 2 other teachers. So here's what you need to know about combinations. Combinations are when the order in which you list or pick things does not matter. When we have a combination, 10C3, that means we have 10 to choose from, and we're going to pick 3. That's everything you need to know about working with combinations.